Today we are designing a rig for convenient test of the Autopilot pump. It is here because something has happened, but well, is in another video. We're supposed to test it when it is installed in the board, and we want to test that it can rotate the outboard, and also this rig for the testing of the Autopilot computer. I have NAC-2 in my case. So nothing really fancy, just some switches. Here, by the way, will be PWM module to correct the speed. Well, it will come later, I'm waiting it, so but you will see for sure. I don't know what level of this video to make for dummies, maybe no, then I need to explain all about double pole switches, but we will see. So I hope you just find something useful for your own project, maybe some ideas, because your market can, you can buy these things on the market easy. So let's see. Let's probably start from the idea, from the schematic. Well, yeah, because I will have this PWM module here. I was thinking if I need to install it in a separate enclosure with another sockets, but no, then I decided to make it different. So I provide the power here through this socket. Well, in my project I use Deutsch connectors. I have a full playlist, everything about them, and also now I found that Amphenol doing much better options for Deutsch connectors. For example, this one that you can seal. Yeah, I don't go deep in this because I did this rig recently and it is on my channel. It is portable fuel indicator gauge. Yeah, so you can see there more details about both of these sockets. So we use the same here. We come with the power here and we take it to the Autopilot pump. So not directly to here, but it is another story. Well, so, and because I have this module here, I want to switch to either to direct battery or through the module. Yeah, so, and this is a switch for testing the motor in either direction. So we come with the power here, provide power to the module, and then we go from the module to these two poles of the switch or directly from the battery. And this is DPDT, double pole double throw switch. So in the middle we switch this power from either power source. Yeah, so the load in our case in the middle, and load in our case will be another switch, that one that is classically connected to switch the motor to either direction. Here optional voltmeter I probably want to install here. Yeah, and here we take the power out from that, but for now I want to install banana jacks here to connect voltmeter to monitoring the voltage. So I will use these part numbers, that one and another one. Yeah, actually I don't need red and black, but okay. Why this one? Because it's sealed on the end. I don't want sealing, I don't need sealing on this enclosure, but anyway I would prefer to have it. So otherwise you can also use these banana jacks. I will put everything in the description as I always do. That's why my videos are so good. Yeah. Well, your likes and subscriptions, please. Well, okay. So as I explained, nothing really fancy. So quite simple. Yeah, that's by the way the switch from Blue Sea Systems. Yeah, so that one. Yeah, in that case they show to switch power to either load, but we use it differently. So you can switch like 4 loads. We actually switch 2 different powers to the load. It's not a problem. So okay, I will think what else I will show you, and let's see. Well, I mentioned another video, but let me show you and tell you. here what you need to use for this small socket. There is part number, yeah, that has this nice round flange. You use 27 drill, and look how perfectly it is on the panel. For the screws I use either 4.8 or 5 and 4.8 screws here. So stainless steel, I have them different. It works perfectly here. For the bigger one, yeah, and you lock this socket with this lock. I don't have it from Amphenol, I have it from Dodge connectors, so that part number, yeah, it doesn't matter. So for the big one, which is for power, that one I will put everything in the description. I have everything always in my video, so that's why you can like me, not me, but my video, and subscribe. Yeah, so for that you need 25. I use 25 drill, and then you need a little bit adjust it so it goes tough. Usually you have 25 here on some enclosures, but not on this one. Here in the place of the clamp you need to work with knife a little bit, yeah, otherwise you can push it this way also, yeah, from the opposite side, of course, yeah, and you lock it with that wedge lock. So in my case it's Amphenol. You should have some stainless steel screws. Suggest in comments how I did these holes. So that's what I have, everything is fixed. And yeah, about enclosure, well, in that case it's not so important, you can use any. I bought it locally, it's actually Spanish, Barcelona. Yeah, so now I need to make wiring. I really love when I found some stuff that is so convenient to work with. Now I'm talking about these banana jacks. You have seen the part number, unfortunately I already disposed it. Look, here you have how to call place to fit this 8 millimeters wrench, yeah. So, and there you have 8 millimeters nut. It's really convenient to screw this one, not just round that you need to hold somehow. Yeah, that is why that is why it was the price 2.5 euro, if I remember right. Yeah, really nice banana jacks. Well, if I told you about these sockets, let me tell you then about the contacts. Yeah, so here for the DT we will use this type of contacts that called pin size 16 for gauge 14 cables, because I will use gauge 14 cables there, because that is the maximum that you can use in DT. In DTP the maximum you can use gauge 12. These are contacts, and I will use gauge 12. Guys, I don't go deep to details because I have a full playlist about those connectors on my channel. So here I will be crimping with different types of tool. Again, I have a lot of video about German and Chinese tools, and about different types of terminals. So I don't go deep now to this. I will do this, and I think the next what you will see is finished design here. Well guys, at the end of Sunday, let me show you what I have here now. Yeah, so that is what I have. Yeah, so I will tell you a few things about these plugs, Amphenol plugs, why not Deutsch, and I will show you just a small test. So, and yeah, I made this connector to integrate between the pump and the computer. Yeah, so here is the pump, yeah, and computer is still there, so I can connect it here. In that case, I can measure voltage, so I just plug to my rig and I connect here voltmeter, and later I plan to integrate voltmeter. I can monitor the voltage this way. It's simple. So however, if we want to test the pump when it's there, yeah, so we provide power from the battery. I do this through this extension cord. I will explain it later to you why it's so long. So yeah, and I have everything is unified in my setup. So these clamps are for chargers, so I connect chargers here. So I have this made by me, yeah. So that's why I use this standard made by me and take power this way to the rig. In case if I take power from the external battery, I want that NAC computer will be disconnected. That's why you have seen I printed this notice for myself: disconnect NAC, blah blah blah. Well, the grammar is not the best, but at least it is short, more or less. Yeah, so when I provide power, I need to disconnect NAC. So we are here. Then we agreed that when I don't use PWM module, I don't have it yet, so we power directly from the battery. I need to switch it here, and then up or down. And we test the pump. When it will be installed there, I will know. So up is starboard or port. Then I will write here. And every time when I test the pump or I do bleeding of the system, I want to I don't want to think, I just want to click, like here, for example, starboard, and the same when I rotating the wheel to starboard, I know that I need to make starboard here. So it will be quite convenient and no mistakes. Well, why that long? Yeah. So first of all, I can connect the battery, which is somewhere here. Yeah, and then I also have that box here. You can watch my video on the channel if already exists, or it will be published later. Then subscribe. So I recently made this one, not yet finally finished. So the battery there is charging through this socket. It means that the battery connected to that socket. When we select here 2, so I can connect that extension cord, the long one here, and take the battery from here to there for the test when I'm here in the garden. I don't need another battery in that case, so it's quite convenient. I unified everything. Well, why Amphenol in that case, not TE Deutsch? So the socket is that one, this is the wedge lock, and these are contacts, because only Amphenol support 10 gauge cable. Deutsch from TE, they ended with maximum 10 for DTP. So DTP, ATP. So, and here they support 10. I crimped it 10. Well, I was still using this tool from TE, yeah, which is the maximum for 12. Yeah, I was a little bit concerned about if I damage or not, but that's what I have. Yeah, so what else? I think that's all. Yeah, and what we have here, there inside, we just have various clamps, crimping connections. I have all this stuff, Deutsch vs Chinese tools, not football. Yeah, so guys, have a good Sunday. Let's see who win. That's quite interesting. England or Serbia? I'm not even sure, but let's see. And so guys, I use this rig now when I'm trying to bleed my system. Yeah, so it goes to another video about all kind of bleeding procedures. So I think you should watch it. It's quite important to know, not entertainment, not interesting, but quite important. So, and here now I just try the rig. So I measure the voltage, but it's not so interesting. It's just either plus 12 one up or minus 12, because we eventually just reverse the straight battery voltage that I got from there. So but here I measure current. I put the current probe here, this fluke, for DC, so it's up to 100 amperes, and I set 100 millivolts in amp, and I got a nice picture that I will go now to the garage and explain here. So we have that one, and it is 1 volt. Yeah, so configuration, and we see about 3.8, so about 3.8 or 4 volts, and because we are in 100 millivolts per ampere, it's about 38 amperes, and that is just classic start of the motor that generates this current. And the normal operation we see here, so it's about it's difficult to say. I should configure it. It's quite difficult to configure this handheld oscilloscope. I have a better one, but it's not handheld. So but we see about so I think 0.8 so about 7 amperes, probably something like that. I can try later more. Yeah, so but at least we can see the start current, and it lasts how many? So what do we have here? 50 milliseconds. So it lasts about 50 milliseconds then. Yeah, about 1 cell. Yeah. I now tested very interesting procedure when you do autopilot in one direction and steering wheel in the opposite, and the outboard remains steady. That's quite interesting procedure. Watch the video about all bleeding procedures, you can see it there. But now we are interested about the current in that case. Well, I will try to show you here. If not, then I will do trigger and go to the garage. Yeah, guys, I think about buying a new oscilloscope with needs 2000, something like this. If you know some good model, let me know. So I set now 200 millivolts. So we see about 4 volts here, right? Yeah. So because we see, yeah, and well, what is the use of this information? Well, just for entertainment. No, actually, when something has happened with the pump, I decided there were suggestions about overcurrent damage. I decided to check the currents there. Well, but the most interesting point, what is the current when the computer NAC-2 do configuration? There is the moment when you should keep the button and release it when it hit the pot side. If you still keep the button, it will still apply current. And I'm quite interesting, does it limit it, and what is the current? So mainly for that reason, but anyway, I just have that rig now, and I can do diagnostic of anything. I can connect in between the NAC also. No, we see 2 amperes. That is not much for some reason. Should be a bit more. Guys, well, when I start configuring trigger, I realized that we start not from the middle, but from here. So we have 1, 2, 3, which means 6 amperes in the maximum, and we are balancing about 2 amperes of this noisy. So now it's quite clear. So you can see that's quite interesting diagnostic. I don't know where you apply exactly this one, but it's quite interesting, isn't it? I also changed the timeline, yeah, and we can see this, yeah. So that's the normal motor operation. Well, for the full picture, let me show you this way. Start, operation with noisy, stop. Okay guys, I do shadow with my hand, and yeah, it works. So it was the start of the autopilot pump when it's already locked on one side. Yeah, so here we see the start of the pump motor, and then is when it's like whoa, and we see 1 volt, and we have 100 millivolts per ampere on the current probe, so 10 amperes. I will try in another direction now. In the opposite direction I got this picture, but probably it's about the trigger settings. I will try now. Push it more. Well guys, yeah, it is. So I pushed again. When it's already locked, we see the start of the motor, and then we see the same diagram. So it's about half volts, which means about 5 amperes in the opposite direction when it's to the starboard. So I guess it's something about steering easy in some direction, not on the water, but for the cylinder. I heard something about it. Well, if somebody knows, let me know. I got my PWM module. Well guys, I don't put the link because you can search this on Amazon or eBay. I think they all are quite similar, and I don't know how it works. I just wanted this shape so that I can make a cut in my enclosure and just fit it there. And I also wanted to have this terminal so that I can use my own wires of a better gauge, yeah, than usually Chinese have integrated. So there, and let's test. Perfectly from the first time. Nice, guys. Like if you like. Guys, Chinese ergonomic, Chinese design. Look at this. Yeah, I fit it in the enclosure. It is designed for the enclosure, yeah, to fit it in. Now I need to wiring this. You got the point. If you didn't, then you probably haven't seen anything better than Chinese junk. Bleh. Bleh. Chinese technology. Let's test. So I finished that one, watched the video about this winch. I connected this test rig here, and let's test. Well guys, I got power from there, from the battery to here, and if you remember, this means that we go through the PWM module, and that is directly from the battery. So I also connected voltmeter directly from the battery. Yeah, the battery is 12 something, yeah, or down. Yeah, you should remember this. So here we read 10. Yeah, it's blinking through the phone, but it is 10%. So you can stop, you can run. I don't know what means this menu. I didn't research it yet. If you know, let me know. So, and then we can increase percentage, but let's start from 10. By the way, so we switch to the PWM module this, and I see, when I push it, I see 13 volts. I don't know why the voltage increased. In this modulation we shouldn't have increased the voltage, don't we? I don't know, actually I don't remember. So, and down -13. Yeah, but guys, well, I now connect it to the pump. Yeah, so, and let's see, you remember we have 7 seconds from lock to lock. Let's see if we can go slower with that. So actually connection is here, not there. This is for the NAC. So the pump is connected, and with 10% we have no movements, and actually we have that voltage under. I think it's because of the load. Let's start from 100%. First check that this model is working. Yeah, so yeah, we do have then voltage, and let's test. Yeah, I think we have the same 7 seconds. I don't want to test right now full 10 seconds. Yeah, so let's try less. So well guys, you have seen I decided to test with 100% to confirm that we still have 7 seconds, and you have seen, you can see the timing, it was 7 seconds. Then I try with, for example, 70%, and look what I have. We have lower voltage, you can see different sound, we have about 8 and we have smaller movement. From lock to lock it takes now about 10 seconds, so it works as it should. We will soon look at the current, but guys, I want to try 50%. Yeah, so for example 50 half. Yeah, so we still see some movement, really slow. It's about 5.8 volts. It's not exactly correctly to use voltmeter to check it because we have modulation. Yeah, but guys, you got the point. It works, and it will be more interesting to see during a NAC computer commissioning with this Autopilot pump, to see what voltage it provides, because it's also used PWM modulation, and it's quite interesting to see how it works. I don't know yet if it will be part of this video for the rig, or I will use this rig for configuration for commissioning computer and the pump, and do a separate video about this. I don't know, I will think, because soon I want to go watch football, but later I will decide tomorrow what I will show you, and I let you know. But now let's still see the current with these tools and see what is happening there. Guys, I want to mention separately that actually you should be very careful with applying a full battery or 100%, so full battery, to the pump. I mentioned this approach several times, but then I discussed with the manufacturer. Well, it's okay unless you hit the end, some lock. Yeah, in that moment you create really huge pressure. So actually we have a kind of debate, I don't know if it was that it's not the current that damages the pump when it's when the outboard is locked and you continue to apply full battery. It's a pressure. So, and it will be quite interesting to see if NAC computer, when you do commissioning and you hold the button and it says please release, also do limit some current somehow or not. I don't know if I explained it clearly, but when I will be doing this commissioning, I will record the video and we will monitor everything here with this rig, and we will see. But just guys, remember, don't hold the button when your outboard is locked. Don't continue to apply 12 volt continuously. Yeah, so it's quite dangerous. I think not for the motor, actually, not about the current, but about the pressure. Well, about the current as well, actually. So, and that's why it's good to have this module that will limit your current. It should limit. I don't know. I don't want to test, probably later, not on the pump, but on some resistors, I will test and let you know, but not on the pump, on the real pump. Just keep it in mind. Well, guys, I think you got the point. I don't want to go to the shadow to analyze this result, because actually the video is not about this. Still, I show you that we have 500 millivolts and there we have 100 millivolts in 1 ampere. I always forget to switch off and battery is drained within couple days. So guys, if you wish to analyze, you can. Yeah, I can do different time scales, yeah, but the video is not about this. The video is about this rig, yeah. So, and guys, it works, and I decided that I need to go to watch football with this video ended. I think that when I will be, not think, but I know now that when I will be doing commissioning between this NAC-2 and the Autopilot pump, then I will use this rig and record another video. It will be interesting to see what voltage applies the computer when it do commissioning. We will see something similar that we have seen here, probably, I don't know. So it will be another video. If it's ready, I will put the link. If not, and you are subscribed, you will get notification. I hope you like this. If you just like, then like. If you found something interesting for you, please let me know in comments, and see you next time. Bye.